Hi guys, welcome back my physical science students. This is Mr. Hescox coming back to you to finish up chapter 4 today on heat and thermal energy. Your warm-up question, what direction does heat move? Heat moves from the hotter object or the warmer object or the one with the more thermal energy to the one with less thermal energy because those particles are moving less. So hot to cold. How does heat move? We're going to talk about the three ways that heat moves today: conduction, convection, and radiation. You'll have a review, and we're getting close to quiz and test time. The three types of heat movement. So the first one there, and the most common, is conduction. This is a process by which energy moves from one object to another when those objects are physically touching. They must be touching in some way. So the particles collide, just like pool balls hitting each other. When those particles collide, the kinetic energy is transferred from one to the other. Most commonly done in conductors. Conductors are something that transfers heat or electricity, in this case, easily. That conductor can be a type of metal like iron. It can be silver, gold. Copper is a great conductor. Perfect example, you left a metal spoon in your pot, you grab the hold of the spoon, burn your hand. That metal spoon allows the heat to flow up by conduction, and then you burn your hand because it becomes hot. So here's my spoon. Looks to me like she's making some type of spiced tea. This would become hot after a while. And the opposite of a conductor is an insulator. Now, a conductor has a very low specific heat because it doesn't take much energy to change its temperature, but an insulator will have a very high specific heat because they're poor conductors. So this is a house being built, and you can see they sprayed in this foam, and that foam has a very high specific heat and will keep your house very, very warm. There's many other types of insulators that you can get, from fiberglass to cellulose sprayed in. And then in the video we watched the other day, talked about denim being shot into your house. Basically, when they talk about this, you have a hot pad, or you may have a wooden handle or a plastic handle on your pots at home to keep you from burning your hands. So those are the insulators. Okay, let's see if it's an insulator or conductor. That's a copper wire. Copper wire is absolutely a good conductor. This is down. These are feathers that would keep birds warm, so that's you got it, insulator. That's a piece of wood. That's an insulator. This is an iron. That is a conductor. This is a cast iron skillet. Also a conductor. Your oven mitt. Your oven mitt is an insulator. The second way of transferring energy involves fluids. Now, a fluid can either be a liquid or a gas, so the particles are moving. Convection is this process in which those moving particles of a liquid or a gas carry heat. In your house, you may have a heat run. That heat run probably blows air that's warmed up by your furnace into your house. Or you may have a hot water run at the bottom of the room that may have hot water from your furnace that runs through it, and that hot water carries the heat into your room. Convection is very, very important for winds and currents in the ocean. It happens because cooler air is more dense than warm air, and the cool air tends to fall below or beneath the warmer air and causes the warm air to rise while the cooler air falls, and it makes these circling effects. And that's rising and falling causes the air to move, and it also helps with the ocean currents to keep them moving. So here, during the day, this is called a sea breeze. What happens? The heat of the day warms the air, and it goes up, it goes out over the ocean where it cools, and then that starts to fall. As it falls, it becomes cool, and pushes itself up underneath these warm air here, this warm air on land during the day because the sun heats up the land and makes it rise. At night, the land cools off, so this becomes what we call a land breeze. The water stays warm longer at night, so the warm water causes air to rise. And that warm air goes up, it starts to cool because this cold air off of the land that loses its temperature because it has a lower specific heat than the water pushes in underneath it, pushing it up. The warm air goes up this way, and you get this cool breeze blowing off the land onto the ocean, and we call that a land breeze. The third way of getting energy is how the sun's energy actually gets here to Earth, and that's in the form of radiation. The sun comes in light. Light travels by electromagnetic radiation. It can be infrared rays, it can be microwaves, it can be gamma rays, but somehow that electromagnetic has to travel through space. Convection and conduction have to travel through material. Radiation can travel through empty space. So it could just be the sun on your skin on a nice sunny day, or you could be putting your favorite Hot Pocket in the microwave, and the microwave radiation warms it up for you. Now this is an example of a thermos. These new thermoses that you can buy, all these Yeti cups, or the ones that I have one that looks like, but it's from Walmart, are insulators, and inside these cups you find empty space. And in this empty space in here, it is literally nothing but empty space. And that empty space does not allow heat to be conducted through. Also, it causes, they're shiny on the inside, so it also radiates radiation back inside your cup. And these types of thermoses that are metal really keep the heat in because they can't travel through this empty space on the outside and in this metal wall here. In your house, you may have different types of insulators in different places, but a vacuum in this thermos is one of the best insulators because the heat cannot get out through this vacuum through the sides. There you can see a different diagram of it. All right, well, let's wrap this up. Is it conduction, radiation, or convection? Here we have a really, really hot piece of steel. That's going to be conduction. This is actually a plate from Haas's. This hot plate is also conduction. I used to work at Haas's. They get really hot and you can burn yourself really easy, hence they put them on this wooden piece. These are ocean currents. Ocean currents. Yep, convection, caused by changing of hot and cold water. This is infrared. This could be radiation or convection because it's heat in the air. Your ice cream melting during the day is going to be radiation as the sun hits it. Boiling water. Boiling water raises in the middle and falls towards the edge and you get this circling. That is convection. All right, ladies and gentlemen, make sure that you are getting your reading done. Get your question done. If you have questions for me, see me in school. And if you have nothing else, I have nothing else to say for today. We are done with chapter 4. You guys be good, be safe. I'll catch you later.